Hi again, this is Tarik Rashid. Today's class research methodology, this is part two, which was again based on introduction to research in engineering. Now, engineering ethics. We mainly discuss engineering ethics in this class. We as engineers are core to major infrastructure projects, dams, bridges, roads, softwares, products, etc. Now, when infrastructure fails due to some natural disaster or events or human error even, engineers must oftentimes bear some responsibilities for any failure. Now, engineering failures in the past have led to loss of lives, environmental damage, and economical impact. Examples of Chernobyl and Challenger space shuttle disaster. Now, professional society established to prevent repeated disasters, promote knowledge sharing, and uphold ethical standards. And the methods for these mentioned establishments is that free exchange of information to share and adhere to codes of ethics. These societies accredit individual and degree programs, set standards, and publish research and failure analysis. I mean, previous research work, we can always analyze the failure of outcomes. Now, importance of accreditation. Research engineers must often be registered to sign off on critical projects. Registration requires formal training, university degree, or adhere to a code of ethics. A code of ethics prohibit practicing outside one's area of expertise. I mean, here as an engineer, you need to work in your field. If you are not confident in any particular field, then you don't have to claim that you are expert in that field and you work there. Now, there's also negligent or harmful practices. Any violation will lead to removal from the register, barring the individual from practicing further. Key tenets of engineering ethics: always act in the best interest of humanity, environment, public safety, which overrides obligation to employers, family, or country. So interest of humanity comes first. Environment, again, one of the key tenets here. Sustainability and public safety are important. Economic viability, engineers must produce cost-effective and reliable outcomes. Phosphate mining lead to climate change and water shortage on small islands. Draining a lake in Central Asia destroyed the local environment and village life. Challenger space shuttle in 1986. Again, it was there was a failure due to O-ring seal mechanical problem. Chernobyl reactor meltdown caused massive casualties and contamination. Now, the Chernobyl was failed due to operational procedure failure to follow the right procedure and maintenance, and created a disaster. Now, ethical principle by engineering organization, examples we could provide here or we could throw: Institution of Engineers Australia, which promotes engineering solutions for sustainable future. Again, there's another example, American Society for Civil Engineers, ASCE, which again focuses on enhancing human welfare and environment, serving the public, employers, and clients with honesty and impartiality. Also promoting the integrity of profession and supporting technical societies. There's also another example we can throw here. Washington Accord facilitates international mobility for engineers by aligning codes of ethics across countries. The bottom line is engineers must follow ethical guidelines in research, especially when it involves human lives or animal subjects. Research should be unbiased, accurate, and not misguided or misinterpreted or misrepresented. Example bias survey, we can go this scenario and we see how a bias survey can harm participants. Now, here's the case study. I'm going to read it and then we'll see the problems in it or implications. A company decides to ask its employees for feedback on their latest product, which was designed in-house. Some employees feel obliged to support product concept because they do not wish to offend the design team or the line manager or the general manager. The net result is biased outcomes of a survey and potential damage to the careers of those employees who did not respond favorably. To avoid the problems of biased research outcomes and perceived or real threats to the participant, an ethical approval procedure must be available to ensure the negative outcomes to the research and the research participants are avoided. So here we try to bring information to be represented to the target group in an understandable way. So we think to avoid this biasness in the survey, we think the first thing, the task should be voluntary. The second, participants are provided with enough information about the task and the risk before starting. The participants are provided with contact details if they have additional questions or feel aggrieved. The participants, again, can withdraw. They have right to withdraw at any time during the survey without any implications. The survey responses are anonymous and the data are stored without the identification of individual participant. And also the last point, which is accumulated result, are provided to the participant when the final analysis has been achieved. Now, these requirements can be achieved in the survey through different methods of approach. First, a common method is to have the work. For example, surveys can be administered by independent organizations. We can use a third party to handle independency. So, you know, why the survey can be only conducted by the employer itself? No, we can go for option of getting a third party to organize the survey. This party will solicit the volunteers and will select the volunteers, and will collect the responses and ensure that the company seeking the data will not be provided with identification tags for individuals. There are now options for online survey, which is better, which are effectively anonymous, and more participant feels better and more relaxed if he or she goes online survey or conduct online survey. The individual profiles used in the survey are not sufficiently specific to each individual, cannot be easily identified. Now, purpose of research. Well, the purpose of research is to generate new knowledge, to the base knowledge that must be validated through several team efforts and through the peer review process by expert in the specific area. Here we talk about the novice researcher. Novice researcher, some of them or most of them, they are not aware of the all details of the results of the research and whether the conclusion is valid and supported by strong evidence. This is commonly done using more than one of the following techniques. Now, method for providing validity, several techniques can be used to substantiate research findings. Experimental measurements using standard tests. We can also use theoretical development to provide a sound conceptual foundation. Also, we can use technique of mathematics and logics to support rational outcome or conclusion. We can always use numerical simulations to model complex phenomena, complex problem. Statistical analysis tools can be used to validate data and results. Comparison with previous published work also is important, and multi-parameter optimization for achieving the best design outcome. So multi-parameter optimization. So you might have so many parameters and optimize each parameter values and select the best values. Multiple validation technique, we talked about it. Multiple method, multi-method can be used to strengthen the result and support the result, and can give us confidence about our findings. Now, there are some challenges which are as follows. No standard method may exist for certain investigations. Statistical support might be difficult due to lack of repeatable measurements. There might be simple theoretical framework which is not adequate to handle complex outcome. Lack of prior research in that area. So the research hasn't been established strongly in that area. And computational model might be ineffective for optimization, and also risk management assessment. You know, when risk it is 0 means doesn't happen, and 1 means already happened. So there is no need to be ready for the risk to happen. So it's a probability between 0 and 1. So it has to be studied. And then importance of supporting evidence. To have research accepted, there should be substantial proofs and supporting evidence. Again, if we continue on this topic, sorry. Now, problems for probability. Now, a glass window in a high-rise building falls to the street below. A structural engineer is asked to calculate probability that this event will occur again. So this is a case scenario, how engineer can see whether this event will occur again. Well, there's a dilemma here because it's only one time happened and we don't have previous record. So a good way to solve this one is that an engineer must check similar event in some other buildings. That's a good solution from myself, so that to collect data on previous records on different buildings which are similar to the building that happened only one time. I mean, this building, a glass window in high-rise building falls to the street below. It's only one record, so this is not enough to verify results. Again, the flight control system in an aircraft is rated as 90% reliable. Would you fly in this aircraft? Well, by looking at the figure, 99% reliable, well, somebody can say, well, why not? I would fly in this aircraft because it has the highest rate, 99%. But the question, the scenario is fake. You know, the flight control system in an aircraft is rated as 99% reliable. But this 99% reliable, this figure, is it for 1 year or per 1 year? Or is it per 10 years? Or is it per a month? Or is it per day? If it's per day, it is very dangerous to fly in this aircraft because imagine Heathrow Airport, how many aircrafts will fly in 1 minute or in 5 minutes. I don't know. I haven't got that much experience in aviation, but for me, 99% is a question mark. You know, is it per day? Or if it's per day, then I wouldn't fly. I wouldn't recommend anybody fly in this aircraft. So it's too much. So out of 100, there's one failure. A civil engineer codes a dam wall as being able to withstand a 1 in 100 year weather event. So a 1 chance in 100 year weather bad event here. Would you be happy to live beneath the dam wall? So is it okay for you to, can you trust this dam wall to live beneath it? So again, this is, we can discuss this scenario. We need to find out what are the chances of the dam wall will be successful or will be not successful for 100 years or even for 1 year. So we can solve this, think about it, and we can provide a solution for this particular scenario. Now, probabilities in real world scenarios, we discussed these scenarios and we're trying to give more solutions. We can always base our knowledge on solving problems, and we can refer to mathematical approaches, finding upper and lower limits, which can provide a good understanding when a complete solution isn't available. I can, again, simplified models can offer bounds to difficult problems. Importance of taking a research project. We do it for rewards. Sometimes we do it because we like research. We do it because it's a career development. We do it because of the excitement, intrinsic motivation. We try to go for discovery. We will be excited if we find new technologies, new discovery can benefit humanity. And can add contribution to the global body of knowledge. So it's a new motivations could be. So there are many reasons. You can also do it for to obtain recognition. Oftentimes engineers, they want to be recognized, successful and then recognized. Career enhancement, career development. We can do it or use research for engineering education. There are many undergraduate programs now include a research project or research methods. Research method has been very important in the life of education and industry. Here we are coming to the end. We can use, I mean, these are the references that I used. I thank you very much for joining this class. Hopefully, stay tuned with the next class. Thank you very much.